We now present a lecture by Andrew Simmonds and Dr. Huda Elsherif, delivered during the 5th ERBE seminar event in January 2025, on the topic of adaptive comfort design for cooling-dominated climates. Andrew Simmonds is a founding partner at Simmonds Mills Architects and leads the newly formed ARC group, focused on architecture, resilience and community. He supports the Cool Buildings programme and Greenspace initiative to make our built environment more resilient. Before leading ARC, Andy served as the first CEO of the Association of Environmentally Conscious Builders, where he helped develop standards for building performance and water efficiency. He created the PHribbon for whole life carbon modelling and ran training courses. Dr. Huda Elsherif is a building physics engineer at Scotch Partners and an associate lecturer at the University of Kent, where she teaches dynamic thermal modelling. Prior to this, Huda completed her PhD at Kent, working to counter air conditioning reliance using mixed-mode ventilation paired with thermal comfort. She explored sustainable strategies to reduce air conditioning reliance in Sudan while developing expert skills in thermal comfort and energy efficiency. The ERBE seminar series provides a platform for discussion and dissemination through themed events sharing innovative ideas and research in building energy performance. The series is co-organised by the SIBSI Young Energy Performance Group and the ERBE Centre for Doctoral Training to promote critical discussion and collaboration. Previous seminar events have covered topics such as test house monitoring, household readiness for heat pump deployment, and global energy supply logistics for net zero. The 5th seminar event included 4 presentations surrounding a new eco-village in Tanzania. These included the design of the school for thermal comfort, empirical research on natural ventilation, mechanical cooling and dehumidification strategy, and a dialogue on the construction process. Please do support the series and attend a future event either online or in person. And without further ado, Andy and Huda's lecture will begin.
Right, okay, so this is a joint presentation with Huda, who is in London. I'm going to do the first bit and Huda will join in and we'll swap backwards and forwards a little bit, so hopefully that'll be smooth. Okay, so just to be clear, so we're going to give you a bit of an introduction. We're going to talk a lot about context. Not a lot. This is quite a fast-paced presentation. Context-specific design. Context is hugely important. We'll do a quick look at the Eco-Village House 5 case study, and then we'll talk a little bit about what we see as the next steps for our work and possible future developments that might help us. Okay, so we're generally focusing at the moment on rural buildings, semi-urban context. So when we started some of this work in Tanzania in 2017, it was quite rural, but the pace of development is remarkable. The number of homes that have gone up since 2017 around the eco-village site has been, shocking in a way. And the development of industry and commerce has been also quite shocking. And I say shocking because what I'm seeing from my perspective of being quite critical of capitalist consumerism is, in a way, a lot of the mistakes that we have made happening at pace and scale in other countries, and particularly the impact on the natural world. Our work is focusing on particularly climate vulnerable countries where economies are struggling. But actually, isn't that all of us? So, but obviously there are absolute differences in people's fortunes. So we are talking about what has until recently perhaps been called the global South. It's a great term. And also we're starting to understand a bit how the work with buildings intersects with this rapid industrialization that I'm talking about and the effect on people's community structures. So the program that we're putting together is called the Cool Buildings program, for want of a better name. It still seems to work quite well. It's quite pragmatic. We're quite pragmatic people. A lot of us do hands-on building work as well as sort of research and design. We like that combination. It's a very powerful combination. We refer to the buildings we do as high performance. That includes buildings such as Passive House, but also these naturally ventilated approaches that we're going to illustrate here, all high performance. we talk about a step-by-step approach. We'll come back to that later, but it's based on the idea that there are many situations where we cannot go straight to high-performance buildings as we perceive them at the moment in this country. A good example is passive house. However, in time, that might become more appropriate. So the question is, how do we go from A to B, or rather A, B, and C? Future-proofing, so optimizing traditional building strategies is key to what we're doing. This is a main theme through the presentation. Understanding how traditional buildings work is one thing, but meeting people where they are, the materials they're using, the plot sizes they have, the way, the sort of access to skills and so on, means that we can't just mimic traditional buildings. The resources have been used up, reed, thatch and so on. People have moved into new areas where materials are more limited. However, there is a lot to learn from, as you all know, from traditional buildings. So understanding what works, what's appropriate in a context, but optimizing it is a core theme. But then thinking ahead that the climate is changing and will continue to change in ways that we're not going to enjoy. So we do have to think about solutions that work now, next year, 5 years, but might not work in 10 years. In this country, if we build a building, it could be there for 200, 300 years. It could be there for longer. So we're time travelers. And then you'll hear me talking about adaptive comfort models versus other comfort models, such as the passive house, the model that the Passive House Institute works based on Fenger's work. Our thrust really is working to the adaptive comfort type models. I asked our main partner in this, Islamic Help, a UK and Tanzania-based global charity. This is our main partner, and we're working with them in ways that they haven't worked before. Basically, they do a lot of reactive charity work, disaster relief, food, shelter programs, but they're looking at more proactive ways to invest ahead of time in helping sort of put the donations they receive into projects which anticipate problems rather than just react to them. But I asked them to put this together because, in a way, the work with them has inspired us to set up this new initiative. So I just pulled out from what they've written for us there some of the key elements of what we're trying to do. So bringing together local and foreign experts is fundamental to what we're trying to do. Operating with mutual respect and shared purpose is very powerful. Being aware of the decolonisation agenda is important, very important. These are things we do bear in mind. I'm not going to talk a huge amount about this, but we're fairly switched on, I would say. The exchange of skills, this is definitely a two-way process and very exciting. So basically the work that we've been doing with these guys since 2017 has led us to set up this new initiative called ARC, which stands for Architecture, Resilience and Community. But really what I'm talking about is a program that we want to run called the Cool Buildings Program. So this is the ARC website, a clunky new website. But you can see there are two programs really, and then the work that we're doing anyway within our architectural practice. So Cool Buildings Program there. We've got a Greenspace initiative, which is looking at the importance of integrating plants, particularly food producing plants, with domestic and commercial projects and learning about that. Again, it's a very hands-on sort of program, but this is the main one that we're active on at the moment. And then we do a lot of new build passive house in this country and retrofit. Very time consuming it is. So just a quick introduction to the Eco Village project we'll be talking about. This is 30-acre site, and basically it's an orphanage, but it's an orphanage that provides the girls with a conventional education, but also some very grounded learning around food production, and the idea is that by creating a more rounded education, they're going to get a better start in life. So the numbers of people since 2012, since the village was set up, has varied on site. Currently, there's only 10 girls on site, but very rapidly we're getting ready to take another 40 children So there'll be 50 children on site with some staff and the house mothers and so on. And just as a sort of quick aside, we're talking mainly about Africa, Tanzania, but the other work that what we're doing here might inform, Islamic help are very keen, it does inform, is work in other countries. So it's just a trip they took us on to Pakistan, where we saw some really interesting work by some local architects. This is partly an open air earth constructed village where they're exploring traditional techniques, but also importantly, exploring the way the buildings were designed to maximize nighttime cooling, cross ventilation, installation related to heat coming through the roof and so on. So you can just start to see some of the sort of material aspects of what's going on over there. Maybe that's another lecture, another webinar. So projects are obviously focused on developing buildings. So here are the sort of 4 streams of work that we've currently got going on. The top stream there started in 2017, 2018, when we were asked to design a new 10-person accommodation to partly replace but add to some existing buildings on site which weren't working very well. So there was a bit of overheating in the bedrooms with the children not sleeping very well. The roofs were substandard and leaking. They had fruit bats in them. Ceilings were rotting out. They weren't in a good shape. So they thought they would try and find a UK architect to work with and develop a new model, a fresh approach, basically. So we persuaded them to build a test unit. So we had the design for the larger building roughly worked out, and then we took some of the key elements we wanted to experiment with and put it into a smaller test unit. So that was partly very useful, partly didn't quite work. So you'll see what we learned from that later on. The reason it possibly was compromised was because the building just wasn't big enough, and we tried to make it into something else as well. We made it into a toilet block. So there's certain things really we lost track of. It didn't give us a perfect test bed, but it gave us a pretty good test bed for some of the things we needed to learn for the main design. That is now built and finished. The second stream here, we've got 4 units like this, mirror-shaped L-section homes built around 2010. 2 of them were never complete. 2 of them were in use until recently. One of them became empty about 3 years ago, and one of them last year, was it? The ceiling fell in, and that was it really. So basically we finished that building just in time to get the remaining 10 girls out and into the new building. So the idea with these 4 homes is to bring them back into use, and to basically what we're looking to do is to apply the things we learned from house 5 in the top there to the existing buildings there. So that's one project that's ongoing. They want to build a school block, possibly 2. So again, we're looking to use things we've learned here in that school project. So we'll be looking to fundraise for that this year. And then finally, a local school teacher, businessman who's involved, is very interested in applying what he's seeing here to his own house, which is a self-built house, which he hasn't quite completed yet. And already he's experiencing some overheating in some of the rooms, and he's very excited by the innovation and the knowledge that he's valuing. So at the moment, he seems to be very convinced to let us advise him on making some changes to that house. So that's a 4th project. In terms of what we're doing, measuring what's going on in the buildings, we use tiny tag data loggers, which are sort of spread out around the house 5. So you can see we've been measuring temperatures with data loggers on the wall, just above the ceiling in that roof space here, and up under the metal roof here. And you can start to see why, because when we're talking about, you'll see later, we're talking about the ventilated heat shedding roof, lots of overhang shading, and lots of ventilation, roof and main rooms, and also the connection between the roof and the building below to allow air movement from below up and out through the roof. So what we're trying to do here is pick up any temperature differentials that are useful to us and understand what parts of the structure are hotter, for example. Saidi is the farm manager at the Eco Village. So basically, he's been downloading the information and emailing it to us. Dowda, who's a local school teacher, he has put a couple of data loggers in his house recently, June last year. And so he's also working with Saidi to collect the data and send it to us. We have a student, Archie Worthington, who's a design studies student in Liverpool. And I think he was taught spreadsheets age 5 by his accountant uncle, which is now proving incredibly useful because he can produce stuff like this for us. And also sort of tabulate results in terms of temperatures and thresholds and so on. So this gives us some really useful insight into what we're measuring. Huda, who'll be speaking in a moment, she's been helping us with understanding thermal comfort models, the experience in practice of what that means in countries such as Sudan, where she's from, where she's an architect. And then Toby Cambry, who is also talking today, has been helping us understand the intersection with passive house, some of the building physics aspects, and also some of the mechanical and ventilation and cooling aspects. Then he's obviously talking about this a bit further on, but this is starting to look at what is the problem that we understand, that we are putting our minds to helping mitigate overheating, either during the day, if the building is used during the day or needed to be used during the day, or at night, particularly at night, bedtime into the evenings for healthy sleep. So again, we're not going to dig into these kind of criteria, what makes a building sustainable, successful, but I think it is worth name checking them because these are hugely important concepts to help us understand how to approach using materials and building constructions on this planet. So sufficiency, which you might be familiar with, is an area where huge wins are potentially available to us in terms of reducing what we need, or rather defining more carefully what we need and not taking more than what we need. So you might see terms like managed degrowth, your fair share, what used to be called contraction and convergence, or equity, which is the concept of allowing countries which haven't taken as much from the planet to maybe use a little bit more whilst we use less, and we meet somewhere in the middle as a sweet spot. We probably run out of time for that, but that is still a good principle to remember. In terms of like building standards out there and the criteria by which they judge whether you've satisfied that standard or not, there are a lot of criteria. We were talking in a meeting this morning, for example, about the EDGE building standard, which seems to have got several thousand buildings on its database, but surprisingly, people don't know about it. Has anyone here heard of the EDGE building standard? Interesting. How many here have heard of the passive house building standard? Okay. So again, we were talking about this earlier in the meeting. When we talk about the buildings we're doing, how do we know they're working? What criteria do we use? What yardstick or benchmarks do we use to say this building is working well? This is just a very simple one that we talked about, which is basically similar to how overheating is assessed in passive house. So how many hours in the year does the temperature of the house on average go over 25 degrees centigrade? That's just one way of looking at it. So we looked at this, but for reasons that become clear when Huda speaks, we're using a threshold of 28 degrees centigrade. And so you can see that over 2023, you can see the overheating percentage, the number of hours each year that the different rooms in the house went over 28 degrees. It doesn't mean they went up to 38, but they might have gone to 29 or 30. You can go above 30 on the whole. Whereas Dowda's house at the moment, one of the rooms in his house we've measured in November is 38 during the day. So you can see, and as Ben will emphasise, there's quite a large range depending on various factors. Other thing to be aware of, getting data on climate from websites. This is data, I think, from the international airport in Dar es Salaam. basically we've measured the external ambient temperature out there. Generally, and we did this in 2017, 2018, we're measuring a little bit higher over the year than the airport data. In terms of like the data we get, how do you read the matrix? How do you make sense of it, particularly when you've got no budget like we have? So Ben's done some really excellent work on this, a much more robust research than we've done, but we have become quite adept actually at finding patterns in the data. This is just room temperatures. So this is Dowda's house here. So this is children's bedroom in there. This is house 3, I think it is. There's a bedroom there. So that's for four girls in there. The mother's room is that room there. So this just shows you the temperature from June last year to yesterday, midnight. And you can just get some sort of sense of things, even from something like that. So that's a lot more lively. The temperature range in Dowda's bedroom, kid's bedroom, is a lot livelier. It goes much higher and lower, actually, than the middle bedroom and the mother's bedroom. So patterns emerge quite quickly if you know what you're looking for. There are various factors that feed different rooms respond in different ways in different buildings, obviously. So the red line here, again, this is Dowda's house. So there are various characteristics of his house. He's painted his roof, he's got black roof sheets, very dramatic, but you can imagine. He has put high ceilings in, particularly high ceilings, very sensible. The room we're monitoring is north facing, it's quite small, it's got one window. It's a 600mm overhanging roof, so there's some characteristics that we're paying attention to. Whereas this house here, this is one of the Eco Village old houses. It's got a low pitch. It's got a green roof, so it's painted a sort of darkish green. It's east facing. It's got one window. It's got a lower ceiling than Dowda's. It's got a ventilation screen over the door, so there is some cross ventilation. But the overhanging roof is pretty minimal. And then the mother's room, which is on the other side of that house, it's got a higher ceiling because it's a monopitch. It's facing south and west. It's got 2 windows. Higher ceiling, trees, so a bit of shading from the trees, ventilation screen again, minimal overhanging. What I haven't put in there is that Dowda has no glass in his windows, whereas these 2 rooms have glass, sliding single pane glass. And again, you drill down, you look a bit at a particular day, and you can see that Dowda house might get hotter. That room might get hotter during the day. I mean, that is a particularly bad day. That is hot. But the nighttime, you know, it's getting towards comfortable, but I would say that it's not comfortable in the bedroom of this house. And this is one of the reasons why Islamic Health asked us to come and sort this out, because this doesn't promote good sleeping, bedtime, into the night. Now, Huda.
Yep. Hopefully you can hear me. I'm a bit sick, so my voice might not be clear. So I'm going to be talking about context-specific sustainable design. Next slide. So context covers a lot of things, but the key one that people really notice is climate. There's a lot of different ways to divide it, but people usually pick either just temperature or they drill it down a bit more into temperature, humidity, and monsoons, like the Köppen climate classification. Next. Now, historically, houses look different depending on the climate they were in. So you can see here a hot, arid house and a hot, humid house. They look quite different. And the reason they had to is because they had to adapt. They had to be comfortable because there's no mechanical system that they can rely on. You can't just turn on the air conditioner. The house has to work. Next slide. But the thing that people forget to acknowledge is that sustainability looks different depending on your location as well. Are you in a village or are you in the city? Do you have lots of space, or do you have the urban heat island effect that you have to deal with? Next slide. And what also is really, really important is socioeconomic context. So here we have 2 buildings. One is a passive house in a city in Korea, and one is the Star Homes project in rural Tanzania. Now, these 2 projects are in the same climate, but they don't have the same access to finance, products, and labor skills. Next. And that led them to choose different ways to achieve sustainability. You have the passive house that went the mechanical ventilation route, and then you have the star homes that went the natural route, just relying on fresh air. Next slide. That difference of choice of what system to go with has led them to change their entire construction. So that air-conditioned building needs high levels of insulation. It has to be airtight. It has to keep that cool air that it spent energy on contained within the building. Whereas the other one is thermally light. It doesn't have any glazing. It's just a completely different direction. Next slide. Now, this is in a context of a hot, dry climate where air-conditioned and un-air-conditioned have very little differences in terms of managing them by using the building, but you also have the fact that night ventilation requires a completely different strategy. So each climate has different conditions that you have to think about. Next slide. And even comfort is subjective and it relates to your context. So here I have two standards, the ASHRAE standards, and one of them uses the adaptive method and one of them uses the steady state comfort method. And you can see one of them thinks 28 degrees is fine, and the other says, no, that is too hot. And that reflects the reality. A person who is used to air conditioning might find 28 too hot, but someone who's living in a naturally ventilated area and who's outdoor all the time might find 28 quite comfortable. Next. So we have to kind of acknowledge all of these differences when we're thinking of what a sustainable house should look like. Next slide. So it could be like the star homes, next. Or it could be like the passive house, next slide. Or actually, in all likelihood, you will likely have a context that is somewhere in the middle where you have to rely on somewhere between both solutions to find something that suits your own context. Next slide. Here we're going to present, Andy's going to present the Eco Village, which is an example of how that has been embodied.
Thanks, Huda. Okay, so House 5. Kamran asked me to do a talk recently as to why the house looked like this, what makes it look like this, which is actually a good question. In terms of key features, I just point out the key features that we focused on. So, long heat shedding roof, basically just the air does heat up in that roof, let it out, let it rise up and out. The old roofs on the houses 1 to 4 in the Eco Village are monopitch, but they have a ceiling and they're not ventilated. I said they're full of fruit bats, but they're also incredibly hot. I mean, there's about 50 degrees or so in there. Whereas this roof space up there is pretty much ambient external temperature. It's basically just a split section, and it has open eaves all the way around. There's nothing closing it off. What it does have is the gable ends are solid, and that's important because what we don't want is air going above and below. We want it going over the top, pressure differentials, and air being pulled up and through the space. It extends out about 2 meters here and extends about 1.5 meters here. And that's to maximize shading throughout the day, shading of the walls. It works very well here on these walls. Orientation. This is south. The other long side is north. So the low angle sun is on the east and the west. On the west, we have a toilet block. Does it matter if that gets particularly hot? Maybe not. Well, in fact, we don't think it did. That's why we put it there. On the east, and we have noticed some slight extra warmth in the bedrooms there on the east because of the sun hitting that east elevation. We haven't put it in yet, but the idea is to have timber battens and to have woven leaf panels on those battens just to provide shading onto the wall and air movement behind so it doesn't build up. I think that will make a difference and also looks nice. So that's the roof, shading, ventilation. The windows, we'll talk about it in a bit more detail later, but basically you notice they're full height. And that was the key idea, was to allow air movement as it moves across the building to come into contact with your whole body. I noticed early on when I visited the site that the houses with the high sills, the moment you sit down, it's really uncomfortable. Now I'm a sort of middle-aged white man, so I'm going to experience temperature and humidity in a different way. But that's a key feature, very important feature. But it does throw up issues of privacy, for example. Okay, so very quickly then, how is housing delivered in Tanzania? Impromptu, get the idea from that picture. Middle class self-built or self-managed development. These are often, I'll have what they've had. I'll have the same house as that, but I want a more impressive roof. I want a taller roof, or I want more bits on it. And that is how we understand it. Most of the housing, the majority of housing is delivered. There is some development going on. I saw some particularly large developments on Zanzibar, on the island of Zanzibar, a Chinese funded bungalow development designed for aircon. If you don't have aircon, you have a power cut, those don't work so well. So there's various problems associated with what we're calling business as usual. So from what we've done at the Eco Village, there are various things which we have been talking about as easy wins, but maybe they're not easy wins. Maybe even trying to change orientation or encourage shading. We've all got economic aspects. So I'm beginning to think actually none of this is particularly easy to change, but it's definitely something that has somewhat cheaper to do. I mean, that's a fairly cheap decision. If you can do it, change the orientation. I'm going to whiz through the site because I haven't got enough time. But basically, it's a 30-acre site. You can see the basic shape of it here. Existing houses are here. The new house 5 is here. The school is probably going to go here. We have a mosque, eco mosque here. And this is where the marsh is. The water rises, and then that provides a stream that goes all the way down through Kisambule down there. This is 2017. This is now very built up compared to what it was. And there's various things going on. You've got boreholes, you've got the natural water, you've got wind from certain directions, you've got factories that don't fulfill their environmental responsibilities, putting stuff into the streams. You've got noise, actually, but mainly amplified noise. They're quite lively churches. Spent a night in the building there and heard quite a lot of late hallelujahs going on from several miles away. Water, polluted water coming off the neighbouring houses. Bear in mind, there's been a 10-year drought across East Africa. A lot of houses have been built in at the time. The rain comes back with more intensity. That's a lot of water that wasn't anticipated. It not only comes off the roofs and into the stump that is the wetland, is the eco village, but also comes off the septic tanks and flushes them out and carries it onto the eco village. So basically, the eco village, really, we've realised, is an ecosystem service treating dirty water. So this has put a whole new slant on how we manage that site. Not something we saw in 2017, but perhaps we should have been aware of it. Okay, so the brief, yes, we will make it up time. Yeah, I'm aware of it. Yeah, I'm busking it. So this is the brief. A very comfortable space. It was under a big shaded tree, out in the wind, very comfortable. So we took that as the brief for the new house. Weather protection needed, insect protection, security and privacy. This is basically the results of what we learned on the test unit. Some things worked well, shading, some things didn't work so well. Cross ventilation didn't get it right, didn't have the right size windows on one side compared to the other side because we went into a toilet block. Perhaps we should have. Anyway, to be honest, making the mistakes was more useful than getting it right. So we improved some of those techniques in the new house. So you can see the windows are bigger, the areas from different sides of the building are more matched. We have larger openings in the ceilings for times when there's no wind and we wanted stack effect. And we had perforated internal walls where we could to allow cross ventilation to be uninterrupted. Windows, there's quite a lot in windows. We worked with Hannah and Otis, who had done a bit of work, who did those star houses, 100 homes. Anyway, they helped us work up some very nice window designs, including these bay window boxes, which had perforated metal screens, insect mesh, and ultimately Venetian blinds, which is a good combination. So, future developments. Well, we've talked about applying what we've learned to the existing buildings. Maybe there's some other things we can do. There's a very interesting organisation called Mirrors Earth's energy imbalance or rebalancing. I can never get it right. But they're looking in places like South Africa, it's a global project, at changing the properties of metal roofing in various ways to insulate, but particularly to reflect heat. They're looking at low cost interventions to be able to make these spaces uninhabitable. It's very interesting. We want to have some good conversations with them. Okay, Huda.
So some of the developments that we're looking at is working on the fan design, making sure the occupant can get the best wind where they are, not just that there's wind in the room. We're looking at using the site design to kind of optimize that ventilation, because again, we're relying on that wind. So we might as well artificially enhance it. And finally, we're looking at future-proofing the spaces by allowing the option of air conditioning to be added. Next slide. Can you move forward a little bit? Yeah. Can you press next? Yeah. Okay. So we're going to bring back this slide. So this is where the eco house currently is. It's more on the naturally ventilated slide. Can you press next? Yep. And we want it to progress more towards the future, which is going to probably be more air conditioned. It's not just because we want to, it's because in all likelihood, the conditions are going to be hotter. The occupants are going to get used to air conditioning in other places. They might go to work and find an air conditioning there and then decide at home they want that as well. So you have to be ready for that eventuality. Next. Can you skip a few more slides? Yep. Next. Yep. Until we get the next slide. Okay. So what have we done? We've created two zones. One will be a mixed mode zone and one will be a naturally ventilated zone. What we're trying to achieve here is that when there is a heat wave, the occupants have somewhere where they can turn on the air conditioner, but they won't be consuming a lot of energy. And it really matters that you have that zone, because in indoor thermal environments, even a reduction of 1% has a big impact because you're staying in that space for a very long time. Can you press next? So how do we actually achieve that beyond the theory? Well, we're looking at insulation. We're looking at, okay, how do we seal up the building temporarily and leave it open at times when it need to, dehumidification, air tightness, all that. Next slide. And if we're looking at PHribbon modeling, which that's what Toby will be talking about. How does that actually work? What should we choose? Because there's so many different ways to do it, but what is the most efficient and a way that will keep our natural strategy also working so that they work in tandem and also give us practical steps. So do this, then this, then this. Next step, next slide. The goal is not to achieve passive house criteria now. We're not trying to achieve that house that's in Korea. We're trying to anticipate that when the project moves forward in that direction, it moves forward sustainably. We're trying to provide resilience for the occupants and give them the option to be comfortable without them going out and deciding by themselves how they're going to make that change, which might not be the best option because it might hinder what's already there, the natural ventilation route. And we're not trying to do pass or fail. What we're trying to do is every little bit counts, trying to make people as comfortable as possible given the conditions and the available materials. And that brings us to our next slide, Andy.
Very quickly, last couple of slides. So does our building work? Well, from the feedback we've received from the people in it, from staying there ourselves, we feel it does work very well. It is a comfortable building, and I'm very fussy about heat. However, what's the hard facts on this? So we're starting to bring together the evidence and also trying to work out what is the best way to show that this building does work. This is, again, going back to that simple just air temperature. So you can see what we've done is put the air temperature from those three projects we looked at. So Dowda's kids' bedroom, the old house 3 and house 5. And this is over a period from June till yesterday. And you can see that the green basically is house 5. If you can make out the extent of the green because it's superimposed, but you can see generally it's more stable, it's more within the central band, and it generally shows lower temperatures throughout the year compared to the other rooms. So a very good indication that we're going to be able to back up our claims that we've created a very comfortable, optimized, naturally ventilated building. So might come back to this one during Q&A. This is really just building on what Huda said, is how do we plan for this long-term route from buildings from where they are now, if we talk about retrofit, or what we build now, to something that is going to have to cope with quite different and maybe more extreme conditions in 10, 20, 30 years. It'll still be there. People will still be trying to live there, or probably. So how do you make decisions now that people will buy into that will allow for future retrofitting, or this concept of zoning and managed retreat from spaces which in extreme weather you just don't use, spaces which you've designed to use even though they're a bit hot, and then maybe areas of the building which are going to have to be taken to mechanically controlled air conditioned zones at some point in the future, without undoing a lot of work that you've done previously. Thank you.